Did you ever get stuck in a bad habit, doing the same thing over and over again, even though it isn't good for you? You're not alone. Even laboratory mice can develop bad habits. Here's an example. We can train mice to poke with their little noses to get a tasty reward. Poke, get treat, poke, get treat. They get really good at this. But then, if we change the rules and make it so you have to stop poking to get a reward, some animals quickly change their behavior. But some continue to poke over and over again. They develop the habit. Neuroscientists have been studying the source of this individual variability and the mechanism of habit formation for decades. 20 years ago, a group working with monkeys came up with a hypothesis, a guess, that was broadly accepted by the neuroscience community. According to them, there are two brain areas in a constant tug of war, competing for control. One of them keeping track of rewards and maintaining flexible behavior. The other indifferent to rewards and controlling automatic behaviors, habits. When animals are learning new associations, that first area is active. As animals consolidate a habit, the second area takes over. But how? The scientists propose that these two brain areas are connected and that activation of the first one leads to dopamine release in the second. Over time, this dopamine helps that second area take control. And as I said before, this idea was broadly accepted. We assumed it was right until now. The problem is this hypothesis was hard to test. It involves a connection between 4 brain areas, but the best we could do so far was test the connection between 2, maybe 3 areas. So what did I do? I combined new tools to push our ability to test the connection between more brain areas. And the results? I'm happy to tell you that this long hypothesized circuit exists. And these are ancient brain areas, evolutionarily conserved. If these areas are connected in the brains of mice, they are likely connected in our brains as well. So proving this connectivity was a big step forward. However, when I activated that first brain area, I did not see dopamine release in the second one. So this hypothesis was only half right. And the search for the mechanism of habit formation continues. The closer we get to an answer, the faster we'll develop better therapies for disorders of habit. Thank you.